Hey, yeah, hi, hello everyone. हेलो दोस्तों, कैसे आप सभी लोग? एक सेकंड दीजिएगा। वेरी वेरी गुड आफ्टरनून दोस्तों, बहुत बहुत गुड आफ्टरनून आप सभी को। एक सेकंड, बस थोड़ा अलाइनमेंट ठीक कर देते हैं। वेरी वेरी गुड आफ्टरनून माय डियर फ्रेंड्स। एक बार कंफर्म कर दीजिए इफ आई एम ऑडिबल एंड विजिबल। Awesome. So good afternoon my dear friends. Everything clear? Okay, great. Perfect. So I welcome you all my dear friends to the revision through PYQ session of algorithms. Okay, and as this is an English channel, so today the mode of communication will be English. Okay, perfect. Can you all please confirm if I'm audible and visible? Can you please confirm it over the chat? All clear? Perfect, perfect. Okay, so first of all guys, as many of you might have met me, my name is Aditya Jain and I am the teacher of algorithms. Okay, and today we're going to be solving lots of PYQs on the topic of algorithms. Okay, now before I proceed guys, I have a very important message to be shared. So you know that the session has got started around at 3:30 instead of 2. The reason I would like to share with you so that you should be aware why it happened. Okay, it's your it's my responsibility to tell you. So actually what happened is that I have a very close friend nearby, and there was a very big family emergency at his home, and there was no one else to help him out. So as a friend, I had to help him out, and due to that reason I was not able to be available at that time which we have set. Okay, so but yeah, thankfully with the cooperation of the team and with your cooperation, it was very much helpful for me to handle both the important events, because your career is also very important, your time is also very important. So I'm the learning here is that if you are a bit cooperative in life, okay, every problem can be solved. Like I was really afraid how I will handle both the things, because your this session is also very important for me, because I can't delay it, because it's your previous year questions practice. It's important for your gate exam, and at the same time the friend situation was also very important at his end. So yeah, with a little bit of cooperation, every problem can be solved. This is the most important message. Okay, chali. With that my dear friends, let's start with today's session. Okay, first of all I would like to know how many of you attended the one shot Maha revision session, although it was in Hindi and was on another channel. But yesterday we had a Maha revision, I would say, lecture. How many of you were able to attend it? Perfect. Okay, so then your concepts would have been very fresh. I see lots of familiar names. Okay, then you have a very good advantage because today your concepts will be very fresh. Okay, perfect. Okay, with that, my dear friends, let's start. Yeah, DP and Heap, that I'll be covering in the next session, the session which is at 8:30 p.m. Okay, so this session is starting at 3:30. The Maha Abhyas session will be at 8:30 p.m. on the GATE CS channel. Okay, so the timings are like that. Okay, chalo. So with that, my dear friends, let's start. Just to give you an idea about today's session. Okay, so as you know, today we are going to revise via PYQs. So we'll be solving lots of variety of PYQs, and yeah, so we'll be solving questions with that. The only thing you have to keep in mind is every question you have to assume as if you are sitting in an exam and this question has been given to you in GATE 2025. Can you all type yes on the chat? You have to solve this, you have to attend this session with such a sincerity that you are sitting in GATE 2025 exam and whatever question I am putting on the slide has been given to you in GATE exam. What I mean by that is when you're solving it at your end, please don't do multitasking. Okay, please don't try to search for the answer. Okay, because all these are previous year questions. Even if you will type the question, you will get the answer. Nothing big in that. Okay, but we are doing this hard work with the message, with the assumption, with the trust that you are here to genuinely get a feel of GATE exam. Okay, so that's why every question you have to solve yourself before I discuss it. So what we'll do is after every question I'll give you around 2 to 2.5 minutes. Okay, depending on the question, and within that duration you have to solve the question and then we'll start discussing it. No one will paste the answer to the question in the chat. You should not paste the answer, you should not paste the option that is correct. Okay, all you have to do is you have to wait for everyone for 2 to 2.5 minutes so that everyone gets a fair chance to answer the question. Is that fine? I hope that's fine. Can you all type yes? This is an important rule, my dear friends. Otherwise it would be very unfair to the remaining audience because then they will not get how exam feel would look like. Okay, and the whole purpose of this would fail. Okay, chaliye. With that basic understanding and with that basic maturity expectation, okay, let's start. So if you're meeting me for the very first time, my name is Aditya Jain and you can go through the detailed introduction later on. Okay, but just to tell you in very short, I have secured All India rank 60 in GATE Computer Science 2019 and I went to IIT Bombay to pursue my masters with specialization in data science, and then I have worked as a data scientist and I have upskilled lots of people in data science domain, and I have mentored lots of people in GATE area as well, GATE Computer Science specifically. Okay, my CGPA at IIT Bombay was 9.36 out of 10. I have also received Excellence in Research Award from IIT Bombay for my master's thesis project, and as a team we have published lots of research papers as well to the well-known conferences. So the detailed introduction you can go from the notes that will be provided to you. More importantly, this is the link to the Telegram channel. Okay, so all of you can join the Telegram channel for GATE exam algorithms topic specifically. I am also on this channel, and lots of peers who are very sincere about their preparation are also available on this channel. So whatever queries you have regarding algorithms, whatever discussion you can have on this channel. Okay, it's a Telegram link. From the PPT you can go, or from the scanner you can have a look. Okay, now just to give an idea, today we'll try to focus on very important topics. First being asymptotic notations, divide and conquer, greedy method, dynamic programming, and some miscellaneous topics like heap, graph traversals, and lots of other topics. Okay, so I'll try to give you a combination of multiple concepts so that your revision is at the highest possible level. With that, how many of you are super duper excited for today's session? Come on. Now we'll directly jump onto the questions without any discussion. I'll give you a question, you have to attempt it, and then we will discuss it together. Okay, this way we will continue the entire session. And you have to keep in mind that as if you are sitting in an exam. Okay, you are sitting in an exam and this question has been given to you. You have to solve it without using any internet, without using any resource, nothing, just with your simple brain and knowledge. Okay, cool. With that motivation, let's start. With this question. This is big omega, this is theta, this is small o, and this is big O. Okay, here I have written the year as well. Sorry. Try your best. I will also try to speak as less as possible in between so that you don't get disturbed. And for easy questions, I will give you lesser time. Okay, that's pretty understandable. If I think that a particular question is very easy, I will give you lesser time. Okay. Again, lots of people are writing answer on the chat. I've told you, you don't have to write answer on the chat. You just have to write done. If you want, you simply write done, but don't write answer on the chat. That's not allowed. Okay, sure. So let Wn and En denote respectively the worst case and the average case running time of an algorithm executed on an input size of n. Which of the following is always true? Hamesha, always true. Okay. So in general, we know that the best case complexity of an algorithm is less than or equals to the average case, which is less than or equals to the worst case. Do you agree? This is a standard property for any given algorithm. Correct? From this, we just have to check the options. So it is saying A is greater than or equal to W, which is not true always. Okay, it is saying A is equal to W rate of growth, which is also not always true. It is saying A is less than or equals to W, which is always true, absolutely correct. And this is saying A is strictly lesser than W, which is wrong. This is not always true. Can you give me an example where this is false? There is a very standard example. Although average case complexity is not in the important category. linear search, the average case and worst case complexity of linear search are both equal. Okay, so the correct answer to this question is C. Okay, and once I give you the answer, you have to write clear or doubt, okay, before I move to the next question. So this is the pattern. I'll give you a question, I'll give you time, you have to write done after solving, then I'll discuss, I'll give you the answer. If it is clear, you write clear. If it is not clear, you write doubt. This is the process we'll follow for every single question. Clear? Perfect. Okay, this is nested loop and this is nested. This is within this is within this. It's a nested loop. Okay, so for every question, I'll give you this timer. Next question onwards. Okay, for this question, yeah. And please don't write answer on the chat. Mm, no worries. So what is the answer? Consider the following function 𝐼𝐗𝐾 equals to 0, I starting from n by 2, okay, n by 2 to n with each time plus 1. So this is order of n. Okay, j is running from 2 to n and each time multiply by 2. Each time multiply by 2. So this is order of log n by 2. I hope you agree. And each time k is getting added by n by 2. Each time it is getting updated by n by 2. So each time it is updating by n by 2, and we have been asked the return value of the function is. So the loop is running n log n times, and each time it is getting added by n by 2. So the return value will be n square log n. Okay, so B is the correct answer. If I would have asked what is the time complexity of this code, then what would have been the answer? Then the answer would have been n log n. Okay, very good. Chalo. Moving on. So it's an easy question. Some of you are still writing answer on the chat. Again, I am repeating, you don't have to write answer on the chat. Once the timer ends, then only you can write answer. Till then, don't write answer. Okay. So what is the number of swaps required to sort n elements using selection sort in worst case? Okay. What is the worst case complexity of selection sort? Order of n square. And what is the best case complexity of selection sort? It is also order of n square. Okay. But specifically, we have been asked about the number of swaps. We have not been asked about the complexity. Specifically, we have been asked about swaps. And whenever we talk about a comparison-based sorting algorithm, two factors play an important role because we are also revising along with PYQs. So the number of swaps as well as the number of element comparison both play a role to determine the complexity. So remember that for selection sort, the number of swaps are always order of n. Specifically n minus 1 swaps. Okay. Cool. Clear? Okay, so the correct answer is A to this question. Moving on. This is a bit advanced question, but a very, very good question. Try this out. You don't have to write answer on the chat. Again, I'm saying. if I repetitively see anyone writing answer on the chat when the timer is on, then I will have to unfortunately block them. Please keep this in mind, my dear friends. Okay. Two alternative packages A and B are available for processing a database having 10 power k records. Package A requires this much time and package B requires this much time units to process n records. What is the smallest value of k? What is the smallest value of k for which package B will be preferred over A? B will be preferred over A. Can you tell me what to conclude from this? What do I need to conclude from this? Packet B will be preferred over packet A. What does that mean? Correct. B will be preferred over A only when time complexity of B is lesser than time complexity of A. Time taken by B is lesser than time taken by A. That's what we mean by preferring something. Okay, that's what we mean by preferring something. Okay, now, so number of records are 10 power k. Okay, A takes 0.0001, so 10 power minus 4 n square time, and B takes 10n log n, 10n log n base 2 units of time. Okay, and in order for us to prefer B over A, okay, what we have to do? We have to make sure that 10n log n is strictly lesser than 10 power minus 4 n square. How many of you are on the same page? Clear? I hope you are on the same page. Okay, then you can cancel n and n. So 10 log n base 2 should be less than 10 power minus 4 n, and you just have to simply substitute the value of n. Okay, so it is 10 power minus k, sorry, 10 power k. So 10 into log of 10 power k to the base, what the base is? The base is 10. Okay, the base is 10. 10 is less than 10 power minus 4 n power k. Okay, that means k times 10 has to be lesser than 10 power minus 4 into 10 power k. That means k into 10 has to be lesser than 10 power k minus 4. And now what you can do is, as the smallest value of k has been asked, you can start from the smallest value 5. Check for 5. So is 50 lesser than 10? The answer is wrong. So k cannot be 5. K cannot be 5. Then check the next smallest value, which is k equals to 6. See, I am showing you how you can save your time. You have to check the options. Specifically 4 options have been given to you. Are you understanding the shortcut for exam? I'm not just solving PYQs. I'm also telling you how a topper thinks in an exam to save their time. I have thought like this. Many of my friends who scored single digit rank, 2-digit rank, they also have this mindset. Presence of mind is very, very important in GATE exam. Okay, so this is not a numerical answer type question. They have given you 4 specific answers and you have to tell from that. Okay, so 5 is not the answer, and as smallest value have been asked, so I will check the next smallest, which is 6. So for 6, 60 is less than 10 power 2, or 60 is less than 100, and this comes out to be true. So the correct answer is 6. Do I need to check 10? Do I need to check 12? Is there any need to check the remaining 2 options? There is no need. There is no need at all. Fine. Everyone clear? Shall we proceed? Are you getting to learn? Okay. Before I proceed ahead, can you please tell me if you are learning from this session or not? Because this is how we'll continue with the remaining session, so that we can solve maximum questions as if we are sitting in an exam. I have to give you these PYQs as an exam environment. So please tell yes or no. Again, don't Google search them, because I have written, see, I have even written the year, so you can easily search the question. But that's not the agenda. Okay. मजा आया क्वेश्चन में? चलिए, very good, awesome, perfect. So let's change the topic a bit. I'll slightly move on to a different topic. I slightly move on to a different topic. For this, 1 minute should be sufficient. Okay, so my dear friends, this question is based on quicksort. Okay, so we have been given an array of n elements, and suppose we implement a quicksort in such a way that always the central element, always the middle element is selected as the pivot. Then the tightest upper bound for the worst case complexity of such a variant is. Now tell me, divide happens before partition algorithm or after partition algorithm in quicksort? after partition. Divide happens after partition. Okay, so it doesn't matter where the pivot is before partition. What matters is where it gets placed after partition. Okay, so it might happen that if this is your array and this is your pivot, okay, it might happen that this is the array and this is the pivot, and you place it at, if this is the array and the middle element you have selected as pivot, but still after partition it might get placed at the first position, thereby resulting in the worst case of quicksort. Okay? So it doesn't matter where the pivot is before partition. What matters is where it gets placed after partition, because divide will happen accordingly. Okay, so still for such a scenario, the worst possible case is still order of n square. So A is the correct answer. Are we all on the same page? Keep, as soon as I mark the answer, you can tell me clear, not clear, so that I don't irritate you by asking clear or not, clear or not. Okay, you can yourself tell me clear or not. Okay, perfect. Moving on. Okay, let's have a different variety now. Think about it. Go on, everyone has to participate to get the maximum benefit. You have to solve it within the given time. Okay, so consider the following array. Which algorithm out of the following options uses the least number of comparisons among the array elements to sort the above array in ascending order? Among the array elements means element wise comparisons. Okay, comparison based sorting wala. Okay, and you have to sort it in ascending order. Okay, now let me ask you something. Will you go to every option and will you apply that algorithm and count the number of comparison? Is it feasible to go to every option and check and apply that algorithm and check? Sir, salute for your teaching style. IIT JEE एडवांस वाला फील आ रहा है. Okay, thank you so much. अच्छा लगा सुन के. It's very good. I'm glad. No, it's not doable. It's not at all doable. Why? Because it will waste a lot of time. Okay, we have to attempt the gate paper in the given amount of time. My dear friends, we'll have a simple observation. Is there anything special about the given array? Did you notice anything special? Yes, the given array is already sorted in ascending order. And that's why presence of mind is very important. Although it has not been given in the question, but we can see that the given array is already sorted in the ascending order. The given array is already sorted in the ascending order. Okay, and we have to sort it in ascending order. So we know that quick sort results in the worst case, which is order of n square. So this is not the answer. Selection sort, we know selection sort number of comparisons are order of n square in both best case and worst case. Will not type cross. Okay, for merge sort we know that always it is of the form n log n, but insertion sort, if the array is already in ascending order and we have to sort it in ascending order, how many comparisons does insertion sort takes? Every pass one comparison, so total of n minus 1, which is order of n. So D is the correct answer. Okay, accurately n minus 1, but still it is order of n, and as compared to the remaining 3 options, it is the minimum. Cool, super duper cool. Super duper cool. Okay, yes, bubble sort will also take n minus 1, but here bubble sort option is not given. Okay, we have to take it from the given options. Okay, try this out. Okay, so friends, this question is a bit different. A max heap is a heap where the value of each parent is greater than or equal to the value of its child. Which of the following is a valid max heap? Okay, so tell me, a max heap follows this property, but what is the prerequisite? What is a mandatory condition for a given tree to be a max heap or a heap? CBT, complete binary tree. Okay, first a tree needs to be complete binary tree even before you check for the heap property. So do you agree that this is not even a complete binary tree. Although here every node is greater than all of its child, but this cannot be a heap. Many people made this mistake in the exam. They marked it as heap, but this is not even a CBT. So this can not be the answer. Okay. So this can not be the answer. We'll check option B, 10, 8, 6, 4, 5, 1, 2. This is a valid heap. 10, 5, 6, 4, 8. Because of this, it cannot be a heap. 10, 2, 8, 1, 4, 6, 10. Because of this, it cannot be a valid max heap. Okay. A node has to be greater than all of its descendant for it to be a max heap. The answer is option B. The only learning thing is A is not a heap because it is not even a complete binary tree. Can you all type yes on the chat? Clear, not clear? Okay, so this was the topic of heap. Okay, let's move on. Let's cover a bit of variety. It's a 2-mark question. Read the question carefully. Okay, I hope you have tried this question. So what is the technique that this is based on? Which concept is this question based on? optimal merge pattern. Okay? This question is based on optimal merge pattern. So what I'm trying to do is I'm trying to give you variety so that you are prepared for the exam. In exam, no one will tell you that this question is based on this subject, it is based on this topic. You have to read the question and you have to answer it in a jumbled fashion. Okay, so that's why I'm trying to give you answers. I'm trying to give you questions in a jumbled fashion. Okay, so suppose PQRST are sorted sequences having lengths 20, 24, 30, 35, 50 respectively. They are to be merged into a single sequence by merging together two sequences at a time. This is the default two-way merging. The number of comparisons, specifically the number of comparisons that will be needed in the worst case by the optimal algorithm. So as soon as they say optimal algorithm, I will think of merging algorithm. I will think of merging algorithm. Okay, 20, 24, 30. 35, 50. Okay. If you have attended the yesterday's session, we have revised all of these concepts. So we prioritize the minimum first. So first priority, second, third, fourth, and fifth. Okay, and then we'll pick the minimum first. So we'll pick 20 and we'll pick 24, and by merging them we'll make 44. So this is gone, this is gone. Which two will I take next? Which two files will I take next? Is it mandatory to take 44 and then 30? Is it right? No, it is not right. Okay, so this is the only mistake people do. This is the only mistake that people do. So you will always pick the two minimum, my dear friends. Okay, so you will now pick 30 and 35 and you will merge them into a single sorted file of 65 records. So this is gone, this is gone. Now you have 50, 44 and 65. So you will pick 44 and 50 and you will merge them into what? 94. And then you have 94 and 65. So you will merge them into what? 9, 159. Is this correct? Do you all agree with this pattern? Do you all agree with this sequence? Okay. So is the correct answer 159? Is 159 the correct answer? No, because 159 is the total records, but ultimately we have made comparisons at every stage. Okay, so all the internal nodes will have to consider. Okay, now here comes a concept. If I would have asked total number of record movements, then it is m plus n. Total number of record movements when you merge two files having m and n records is m plus n. But here we are talking about merging comparisons. And when I talk about comparisons, the minimum comparisons are minimum of m comma n, and the maximum comparisons are n plus n minus 1. Do you agree? Minimum and maximum comparisons. Okay, so this is what we need to take care of. So it will be here the maximum comparisons will be 159 minus 1. Here it will be 94 minus 1. Here it will be 44 minus 1. And here it will be 65 minus 1. Okay, so answer equals to 159 minus 1 plus 44 minus 1, 94 minus 1, 65 minus 1. Okay, so what, this is again 159. So 159 plus 159 is 160 into 2, 320. So 320 minus 4, 320 minus 4 plus 43. 320 minus 4 is 316 plus 43. This becomes 953, 359. Is 359 the correct answer? Four, 324, 443. Okay, have you made any mistake? 159, 159, 44, 94. Have you made any mistake? Is there any mistake here? What do you think? Correct. So year minus 1, year minus 1, so minus 2, and year minus 1, so it has to be minus 5. Year is the mistake. Okay, so I was thinking that someone will point it out, but no one pointed it out. Come on guys, you should point it out. It is 358. This should have been 5. Minus 1, minus 1, minus 1, so minus 3, minus 2. Okay. So the correct answer is 358. 359 is wrong. Shall we proceed? Okay, so this is how you can solve any question on optimal merge pattern. Very beautiful question. I hope this concept is super clear. बहुत बार पूछा गया है एग्जाम में, lots of times it has been asked. Okay, the only mistake you have to avoid is this. The only mistake you have to avoid is this. Always consider the minimum 2. Okay, let's go ahead. Moving on. Very good. This is one of the most advanced question. One of the most advanced question ever asked on this topic. Okay, so my dear friends, this is one of the most advanced questions ever asked on the topic. Okay, now if you have attended yesterday's Maha revision session, okay, which was around 8 hours long, okay, I hope that you have attended that. So if you have attended that, I promised you something, that in this previous year question session I will cover the MCST questions which are very important. Do you remember that? I promised you, because yesterday we were not able to cover MCST questions. So I promise you that in previous year question session I will give you very good questions on this topic. Okay, so that's why I have brought these questions for you, which are very important. Okay, perfect. The question is, the graph shown below has 8 edges with distinct integer edge weights. One of the very important point. Now guys, I'm not just here to give you answers, but I'm also here to give you tips and tricks so that you can get the maximum possible marks in this subject. So one tip that I have noticed among every topper, okay, every topper has one thing in common. Whenever there is some given data, they read the question very carefully. You might think that, sir, it is very obvious, but no, it is not obvious. I see lots of people who rush very fast to read the question and they miss the important information. It is well said, means when I was at IIT Bombay, people used to say that if you read the question carefully, you are already 50% done with the question. And I totally agree with that. If you read and understand the question carefully, you have already scored 50% marks. Okay, but if you hurry, then you will lose every single mark. So first important point is that all the edges are of distinct weights. Okay, the minimum spanning tree is of weight 36 and constrains the edges. All the edges that are marked are present in the MCST. The edge weights of only those edges are in the MCST are given in the figure shown below. The minimum, see, I am highlighting the key points. You have to keep in mind the key points. The minimum possible sum of weights of all the 8 edges of the given graph is. Now I have to find the sum of all the edges. Okay, but do you agree that in order to find the sum of all the edges, I need to find these 3 missing weights? Because if there are 3 missing weights, I don't know what to add, correct? I hope you agree. Okay, so what will I do is I will try to find the missing weights. Now if I draw the MCST, okay, this and this, these edges are part of the MCST. So why is this edge not part of the MCST? If this is 2 and this is 9, any specific reason? So if you have learned MCST properly, do you agree that in any cycle the maximum weight edge will never be part of the MCST? Yes or no? This is a property, indirect property, that the maximum weight edge of any cycle will never be part of the MCST. Okay, so if AB is not part of the MCST, then it is guaranteed that its weight is greater than 9. For it to be maximum weight, its weight has to be greater than 9. Its weight has to be greater than 9. Okay, just tell me yes or no, because 9 is there, 2 is there, so it has to be greater than 9. Okay, similarly, if I consider this cycle, this is 4, this is 6, this is 4, this is 6, and this is missing. So within this cycle, your ED has to be greater than 6, because 4 and 6 are already there. So for it to be greater than, for it to be the maximum weight edge, it has to be greater than 6. And if I consider the entire cycle, 15 is the maximum so far. So this has to be greater than 15. Just say yes or no. Come on. यहाँ तक till here everyone clear? Till here everyone clear? Okay. Now if AB is greater than 9, if AB is greater than 9, what all options do I have? What all options do I have? I have 10, 11, 12 and so on. Infinite possible answers are there. Infinite possible answers are there. But what is that important point here? What is the important point in the question that will help me figure this out? From the infinite possibilities, this minimum word, because it is asking me the minimum possible weight, I have no option but to select the minimum possible value. Okay, so I will go with 10. I cannot pick 9 because then it will be duplicate. Okay. So I will go and fix 10. Then similarly ED has to be greater than 6. So 7, 8, 9, lots of possibilities are there, but I will pick the minimum one, minimum possible value, which is 7. And similarly your CD has to be, your CD has to be greater than 15. That means 16, 17, 18, anything. And for minimum overall, I will pick 16. Okay. So I have fixed it to be 10, 7 and 16. And already it is known that these MCST weight is 36. Total cost of graph equals to 36 plus the remaining, which is this and this, 10, 7 and 16. 10, 6 and 10, 16 and 17. So 36 plus 17 plus 16, that means 33. So the final answer to this question is 69. क्या लगता है? What do you think? Okay, so every single point is important. Distinct is important, minimum is important, and that's why toppers always keep in mind the important points. If you miss these important points, you will be confused and you will never get the answer. Okay, so with this, my dear friends, with this we are done with this question, and the answer is 69. Let's move ahead. Are we ready to move ahead? Okay, it was a 2-mark question. Very, very good and conceptual question. Okay. Come on, yes or no? Perfect. Try this out. You have 1 minute. Write done once you are done. Come on, it's a 2-mark question. So consider a max heap represented by the array 40, 30, 20 and so on. Now consider that a value 35 is inserted. A value 35 is inserted into this heap. After insertion, the new heap is okay. So first with this, I would like to tell you what is one mistake that people do. What is that one mistake that people do? The biggest mistake is that people directly insert 35 towards the end. Okay, so 40, 30, so on, and 4 ke baad they put 35. After 4 they put 35. So this option comes out to be correct that way. But is this the right approach? See, I don't want to just give you the right answers. I also have to tell you the mistakes to avoid. Okay, and this is the mistake you need to avoid. This is the mistake you need to avoid. Don't just take a shortcut and attach 35 towards the end. That's wrong. Okay, because it's insert operation on a heap. Okay, it's insert operation on a heap. So first you will create heap 40, 30, 20. You will create heap in a complete binary tree fashion. Okay, so 40, 30, 20, 10, 15, 16, 17, 8 and 4. This is a given heap. Now into this heap you insert 35. Into this heap you insert 35, and as soon as you insert 35, it no longer remains a heap and you have to put this at its correct position. So you will go with the insert operation on heap. How does insert operation works? Whenever you insert any element, you have to check with its parent, and if parent is greater, you have to swap the parent here. 15 comes here, 35 comes here, and you have to keep doing this recursively till you reach the correct position. So 35 will again be swapped with 30, and 35 will be checked with 40, but there will be no problem. Okay, so the answer is 40, 35, 20. 40, 35, 20, 40, 35, 20, 10, 30, 16, 17, 10, 15, wrong, 10, 30, 16, 17, 8, 4, 3, 15, sorry, 8, 4, 15. So this way the correct answer is B. Are we all on the same page, my dear friends? Okay, so we have solved good amount of questions. Okay, we have solved good amount of questions. I'll wait here and I'll ask for your genuine feedback. Please share your genuine feedback. Are you guys getting benefited? Is this PYQ session helping you revise and get to the level of previous year questions? Get to the level of GATE? Do you think you are actually getting more confident with every question? Okay, I'm trying to cover as much variety as possible. Okay, I'm trying to give you very, very different and unique questions. Too much benefited? Okay, perfect. Thank you for your honest feedback. I hope that you are giving honest feedback. Okay, if you find anything, let me know. Very informative. Perfect. Thank you. That's the whole agenda of this session. Moving on to the next question. Okay, So these are some theoretical types of question that got asked in GATE exam. Chalo, try your best. It is one of the most amazing theory question ever asked in GATE. Theory questions are very logical. Okay, another very good question. So let G be a weighted connected undirected graph with distinct positive edge weights. If every with distinct positive edge weight, if every edge weight is increased by the same value, then which of the following statements are true? Minimum spanning tree of G does not change. How many of you agree? If you remember, yesterday we solved a question in the Maha revision that the exact same structure will be there. The edge weights will be different, the total cost of the MCST will be different, but the exact same structure will be there in the MCST. Because why? Because the relative comparison will still remain the same. Every edge will relatively be the same. The minimum will be still minimum, the maximum will be still maximum. Yes? Okay, so this is absolutely true. How many of you agree? Statement P is absolutely true. Okay, now let's think of statement B. Okay, second statement. Here, shortest path between any pair of vertices does not change. Okay, now I'll tell you one very easy logic that toppers use. I have seen this among almost all my batchmates at IIT Bombay, that whenever such types of questions are asked, what they do is they try to come up with a contradictory example. Okay, so if you are solving any theoretical question and you don't know how to answer it, you don't know the property, all you have to do in exam is you have to think of a contradictory example. Can you type yes on the chat? I am telling you this important tip that is not just for this question but for almost every such type of question. You just have to come up with one example that contradicts this fact. And if you are able to solve such example, if you are able to figure out such example, then you can answer it as false. Otherwise, it is true, because if no such example is there. Okay. What I'll do is I'll try to create a graph such that the shortest path will also change. Okay. Let's take an example. So suppose I have A, B, and C. Okay. Let's say this is 5, this is 7, and this is 10. 5, 7, and 10. Okay. Let me take different numbers for easier calculation. 3 and 10. 5, 3, and 10. Okay. If I ask you what is the shortest path between B to C? B to C, what is the shortest path? Can you tell me logically? it is B, A, C. Okay, B to A is 5, A to C is 3, and this comes out to be 8. This comes out to be 8. Okay, perfect. And if I do plus 20, if every edge weight is increased by plus 20, what will this become? A, B, C, 25, 23, and 30. Now on this updated graph, if I ask you, what is the shortest path between B to C on this updated graph? So the shortest path is, this is 25 plus 23, which is 48. And if you directly go B to C, it comes out to be 30. So this is the shortest path. The shortest path is changing from BAC to BC. Okay. And my dear friends, that's why this statement is false. This is saying any does not change. Any means always. It is saying always it will not change. Okay, which is wrong. So it may or may not be true. It may or may not be true. Okay, so only statement P is correct. Did you get how to solve such question? Super clear? Perfect, perfect, very good, awesome. Moving on to a different question. Okay, but first let's cover some variety. Okay, I'm just trying to give you a bit different question. Try this out. Think about this question. Okay, let H be a binary min heap consisting of n elements implemented as an array. what is the worst case time complexity of an optimal algorithm to find the maximum element? It's a min heap and we have to find the maximum element. Okay, so there are lots of approaches. Okay, there are lots of approaches. Do you agree? Do you agree? The first approach is I can actually sort this using heap sort. I can actually sort the given array using heap sort. But what is the complexity of heap sort? What is the complexity of heap sort? N log n. The complexity of heap sort is n log n. So I can definitely do this in n log n time. But I have to give the best possible worst case complexity. Okay, among all the worst case, I have to choose that algorithm which solve this in the least possible time in the worst case. Okay, so n log n can definitely be the answer, but can I do it in better? So do you agree that I can convert a complete binary tree into any heap, min heap or a max heap, by making use of Heapify? How many of you agree? I can convert a complete binary tree into a heap, either min heap or max heap, by using the concept of Heapify. Okay, so I can also convert a min heap to a max heap. I can convert a min heap to a max heap using Heapify. Okay, and once I have the max heap, where will the maximum element be present? In a max heap, where will be the maximum element present? At the root, and I can access it in constant time. Okay, so the overall complexity of this approach will be order of n. Why? Because the time complexity of Heapify algorithm, okay, the time complexity of Heapify algorithm is order of n. Okay, so with that logic, my dear friends, the correct answer is option n, because it is better than n log n. Okay, so do you remember I told you, I promised you in yesterday's session that I will also give you heap related questions along with MCST questions. Do you remember that promise? I told you specifically that heap is a topic which is better understood with the help of questions. There is very less to study there. It's all about question solving. Very less concepts are there, but how you apply those concepts is the important part. Okay, so that's why today I am trying to give you heaps questions as well, so that you get understanding about it. Is this clear? Let's proceed. This is clear. Let's proceed. And you have been given the link to the Telegram official channel. You can also join that, my dear friends. Okay. Okay. Sure. Very good. Moving on. Yeah. Very, very good question. Very advanced question actually. Sure. Please solve it carefully. Very, very good question and very recent question. Okay, so as no one has given the answer, I'll give you 1 extra minute because this is a lengthy question. So you have 1 extra minute. Try this out and write done. Come on. The question is a bit tricky. Okay. So friends, I have given you this question to tell you one important point. See, in GATE exam, you have to have a very good presence of mind and you need to be very optimistic. Okay, so the point is, it might happen that some questions will take you only 30 seconds. Okay, and it also might happen that some questions can take you 5 minutes. Okay, so there can be both types of questions. You have to save time in the easy question and you have to utilize them in the lengthy questions. This is how you have to manage your time. As a topper, every topper has a very good time management strategy. Like, for example, if I talk about myself, I calculated that I will be approximately spending 2 minutes per question on an average. Okay, does that mean that every question I will take 2 minutes? No, it's very possible that some questions will take 40 seconds, some question might take 5 minutes, some question might take 4 minutes. You have to have a good presence of mind to decide which question should take more time, which question should take less time. Okay, so please have a strategy. I have shared my strategy on the GATE channel, on our channel sometime back. If you don't have any strategy, you can use that strategy. But if you have any strategy, please follow that. Okay, don't change the strategy at the last moment. Okay, perfect. So consider the string ABB something something. Each letter in the string must be assigned a binary code satisfying the following properties. For any two letters, the code assigned to one letter must not be a prefix of the other. For any two letters which occurs earlier in the dictionary order is assigned a code whose length is at most earlier the length of the code assigned to the other. Among the set of all binary code assignments which satisfy the above property, what is the minimum length of the encoded string? As soon as someone asks you minimum length of the encoded string, what will come to your mind? Binary encoding, minimum length. If you mix these two concepts, Huffman encoding. If you mix these two concepts, you get Huffman encoding. Okay, Huffman encoding is application of optimal merge pattern. Okay, so first point is that you have to identify what concept is this question based on. Second important point is, in Huffman coding, okay, the standard approach is that you are always given a frequency table, probability table along with the string, along with the characters. But is any such information given here? Tell me. Have you been given any probability table? No, you have not been given any probability table. Okay, and this is what separates this question from any standard Huffman encoding question. Here you have been given the string, and from that you have to get that information. From that you have to get this information. So the given string is A, B, B, C, C, D, D, E, E, E. This is the given text. Okay, so if you figure this out, A is having frequency 1, B is 2, 2, 2, and 3. Okay, so in order to handle this ambiguity, because here it's an ambiguity, you can take anything before, I can take anything before. So in order to handle this ambiguity, you have been given this point number 2. How many of you notice that? Point number 2 is very important. Okay, so it is clearly telling that the length of B should be lesser than length of C, should be lesser than length of D. Okay, because B, C and D are having equal frequencies. Okay, so in order to handle this case, if length should be lesser, should they be below or should they be above in the tree to handle this case? Length lower means they should be above. Length is calculated from top, not bottom. Length is calculated from top, so they have to be top. Okay, so B will be ahead of C and ahead of D. So priority wise, first priority, second, third, fourth, and fifth. Did you get it? This is the most important step. Remaining thing is easy. This is important. Okay, that's it. And yeah, you will apply Huffman encoding. Three, then 2, 2. You will take 2, 2, CD. Then you have 3, 3, 4. You will take 3. And it's a standard that every time the lesser should be on the left and the greater should be on the right, although it won't matter in this question, but still I will bring C, D here. Do you agree with this tree? Do you agree with this tree? Okay. Then the second step is you have to give encoding. Left 0, right 1, 0, 1, 0, 1, 0, 1. Left 1, right 1. Okay. So encoding for A is 1, 0, 0. Oh, guys, we have done one mistake. So I will actually take A and D, sorry, and this will be B. Okay, this is one mistake. This is one mistake. Okay, D should be lower. Okay, so B is having 0, 1. Okay, these are the encodings. That's it. Once you have encoding, you have the text and you have to tell the total number of bits. So there are many ways. The first way is you can write down the encoding. Do you agree? That's the first way. If you have attended yesterday's session, I told you the 5 to 6 different types of questions that can be framed on Huffman encoding. Do you remember that? Do you remember that? Okay, and this was one type of question, that for the given text how many bits will be required. Okay, so there are many ways you can encode this, and then you can count the total number of bits. This is one way. The other way is that you can just calculate. So A is present one time and 3 bits are required each time. B is present 2 times and 2 bits are required each time. C is present 2 times and 2 bits are required each time. D is present 2 times and each time 3 bits. E is present 3 times and each time 2 bits. Okay, so you can just add it. Comes out to be 23. It comes out to be 23. Okay, so the correct answer is 23. More than the answer, is the entire discussion clear? Because this is the only question on Huffman encoding that we'll be solving today. So from this entire question, I have covered the entire topic. Is that clear? Yes or no? Hmm? Perfect. Now let's talk about a very unique question. Yeah, one of the very unique question. Yes. One of the very unique question. So this is one of the most unique questions ever asked on this topic of MCST. Okay. So consider the following given graph. Choose a value of x. We have to choose because x is a variable. Okay. So we have to choose a value of x that will maximize the count of minimum weight spanning trees, MWSTs. The number of MWSTs of G for this value of x. Now my question is, because so many times I have seen this mistake in the lectures as well, do I need to give the value of x as the output? Are they asking the number of MCSTs or are they asking the value of x? Read the question carefully. 50% battle is in reading the question correctly. They are asking the number of MCSTs. They are asking the number of MCSTs for this value of x. For such a value of x, what are the number of MCSTs? Okay, perfect. So you have to first figure out the value of x and then you have to figure out the number of MCSTs. Okay. By the way, we should stop taking the variable x. X variable is not a good variable, right? It reminds a lot of people about lots of things on the funny side. Okay, chaliye. I hope you understand what I mean. Yeah, चलिए तो चलते हैं आगे. तो भाई किस तरीके से, how do we need to solve this question? Let's have a look at that. So 1 2 3 4 5, okay, like this it has been given. Some people are laughing. Okay, so those who have understood, that's good. Okay, 4 1 4 4 4 1 4 4 x 3 5 x 3 5. Okay, now see, this is a very interesting question. So let's say I apply Kruskal. I don't know what the value of x is. I apply Kruskal. So I will draw the structure like this. Okay. Now I will start picking the minimum 1 and 3. 4 will never be part of the MCST. Now do you agree that from this and this both are 4 and I have to select 1 in this entire side? In this entire side I have to select 1, so I have 2C1 options here. I have 2C1 options, and here I have x and 5, x and 5. In this cycle I have to again select 1. Okay, my dear friends, here there is no ambiguity. Here you have 2C1 options, but here depending on x, depending on the value of x, your answer will differ. If x is greater than 5, so there are 3 possibilities. There are these 3 possibilities. Okay, why I'm comparing it with 5? Because 5 is the maximum weight so far. So I have to decide whether x will be present in MCST or not. So that's why I'm writing these 3 cases. Did you understood why I write 5 there? Yes or no? Why I'm not comparing with 6? Why I'm not comparing with 2? Is that part clear first of all? Because its competition is with 5. Its competition is not with 3. 3 will always be part of the MCST. Okay, so we have to decide in this case. When x is greater than 5, do I have any option? No, I will have to select this 5. In this case, 2 possible MCSTs are possible. that will come from this side. If x is lesser than 5, then also I don't have any option, because then this will be excluded, this will be included. Then also two MCSTs are possible. Okay, but when x is equals to 5, when x is equals to 5, then this becomes 5 and this becomes 5. Okay, so I have a cycle 3, 5, 5. How many ways I can pick two edges? Two C1 ways. In two C1 ways. Okay, from two 5s I need to pick one. So here there are two possibilities, here there are two possibilities. So total there are 2 into 2, 4 possibilities. So for x equals to 5, I have 4 possibilities. Okay, so we have to choose that value of x for which the number of MCSTs are maximum, and that count of maximum MCST is 4. So the value of x is 5, but the number of MCSTs is 4. So the answer is 4. Did you all get the question? Please tell very honestly, because I am expecting, personally, I don't know, I have not studied the GATE paper, I don't know, but personally I am expecting that there will be definitely a 2-mark question on MCST topic. This is my experience, this is my gut feeling, that there will be definitely a 2-mark question on MCST. Okay, and it can be aptitude mixed question. Personally, I think that such types of questions are very important. सर x ग्रेटर देन 5 के लिए एक्सप्लेन कर दीजिए प्लीज. x ग्रेटर देन 5 रहा, आप बताओ. If x is greater than 5, let's say 6, so this is 6, this is 5, this is 3. How many ways can you select 2 from that cycle? Nikhil. 3, 6, 5, you will select 3 and 5. There is no choice. So that's why only 2 possibilities which are coming from this side. Okay. I hope that this was clear. Okay, let's move on to a different question. Very advanced question. For this, I'll give you 3.5 minutes. Please think wisely. Don't randomly guess. Actually, for this, I should give you 4 minutes because the question itself is large. Think properly. And such questions will take you more time in exam. You don't have to worry. It's fine. We have not covered this concept today, so it will give you a good idea. I hope you are able to solve this. Very good question. Okay. Consider the weights and the values of the items listed below. Note that there is only one unit of each item. Her item sorry sorry, every item is present of only one single quantity. Okay, the task is to pick a subset of these items such that total weight is not more than 11 kgs and the total value is maximized. If I only read this much, can you tell me what is the topic? What is the topic? What is the topic of discussion? What is the topic of discussion, my dear friends? Knapsack. It's a knapsack problem. Okay, this is a knapsack problem. This is a knapsack problem. Very good. This is a knapsack problem. Okay, but knapsack are of two types. Knapsack are of two types: fractional knapsack, binary knapsack. And depending on the answer, depending on the question, we will decide which technique to use. Moreover, no item may be split. No item may be split. So what type of knapsack? What type of knapsack? It's binary knapsack. The total values of items picked by an optimal algorithm is denoted by the opt, a greedy algorithm. Although it is binary knapsack, but still they are saying that you have to use a greedy algorithm. So greedy algorithm sorts the items by their value to weight ratios in descending order and packs them greedily starting from the first item in the ordered list. The total value of the greedy algorithm is denoted by V greedy. What is the value of V opt minus V greedy? Very good question. Very, very good question. Okay. Very, very good question. My dear friends, ये क्वेश्चन ना बहुत ही यूनिक से भी यूनिक है. बहुत ही यूनिक क्वेश्चन है ये. बोला क्या जा रहा है कि आपको कुछ आइटम्स दिए गए हैं, वेट दिए गए हैं, प्रॉफिट दिया गया है और आपको बोला जा रहा है कि भाई आपको बाइनरी नैपसैक लगाना है इस पे. लेकिन इस बाइनरी नैपसैक को आपको ग्रीडी से भी सॉल्व करना है और ऑप्टिमल टेक्निक से भी सॉल्व करना है और दोनों से जो आंसर आ रहा है उसका डिफरेंस बताना है. बताइए ऑप्टिमल टेक्निक क्या है? व्हाट इज द ऑप्टिमल टेक्निक? ग्रीडी ऑप्टिमल है? नहीं. और बाइनरी नैपसैक greedy is not optimal. DP is optimal. Okay, DP is optimal. So we will apply DP and we will apply greedy for the same problem. Now, do we need to apply DP? Not exactly. Why? Because this question data is so simple that we can solve it manually. We can solve this manually. Okay, so we have 10 7 4 2 and we have a capacity of 11. So do you agree for 11 I have multiple combinations but very limited combinations? I can have these two, which will be 48, but none of them will be greater than 60. So I can conclude that V optimal will give me answer of 60. Just say yes or no. I can have all the possible combinations manually. I can pick this, I can pick these two, I can pick these two, but none of the combination will give me more than this. Correct or not correct? Correct. Okay, very good. Okay, now I will solve this by greedy. Okay, so for greedy, the P by W value is 60 by 10, 6, 28 by 7, 4, 20 by 4, 5, 24 by 2. This is what we do for greedy. Just say yes or no. This is what we do as the first step for greedy. Right? Correct? Correct? Okay, okay. So my dear friends, this will be my first priority, second priority, third priority, and fourth priority. Okay, I will prioritize that object which is giving me maximum P by W, profit per unit weight. Okay. Okay. So now to solve greedy, I have M as 11. So I will first pick this object. So 11 will become 9, and V greedy will be added by 24. Okay. I have taken entire this object. Then I will go to next priority, and it will consume 10 capacity, and it will give me a profit of 6. It will give me a profit of, sorry. Am I doing any mistake here? Oh yeah. So can I pick this object? Can I pick the first object? No, because it is taking 10 units weight and I have only 9 units of weight, and I have to solve this in greedy with binary knapsack. So I will have to skip this object. I will go to next object, which is of weight 4 and giving me profit 20. So 4 will go and 20 will be added. And then I will go to next object, which is 7 and giving me 28. But unfortunately, I cannot do it. I will have to stop here. I cannot accommodate any item apart from this and this two. Okay, so this way I am still left with 5 weight, but I cannot have more than 44 weight. This is V greedy, this is V optimal, and the answer is 16. So 16 is the correct answer. Am I clear? Am I clear, my dear friends? Do you agree with me? The only question, this is the only question that we'll solve today on knapsack. So I hope that this is clear. End-to-end knapsack is clear. Greedy as well as DP. For DP, you can create metrics and all, okay, but not required. Very simple. Okay, let's move on to the next. Please tell very quickly, clear or not. Very important question. Shall I move to the next question? Yes or no? Perfect. Okay, let's see. Oh, let me try to give you a very different question. Very good question. Come on. Again, as I told you, MCST has very unique variety. Try this out. One of the most unique question ever asked on this topic. Okay, let B be a complete undirected graph with 4 vertices having 6 edges with weights 1, 2, 3, 4, 5, 6. The maximum possible weight that a minimum weight spanning tree can have is a very unique question. It is asking maximum MCST cost, maximum weight of a MCST. So maximum and minimum together. Okay. Now my question is, don't you agree that I have taught you yesterday that the cost of MCST is always unique? How many of you agree? It's a property that the cost of MCST is always unique. Okay, so from where this maximum cost of MCST comes? Then what is the meaning of this maximum? If MCST cost is always unique, why they are asking maximum? Can someone tell? Question is easy, the concept is important. So guys, the difference is that when the graph is given, when a specific graph is given, in that case the cost is unique. I hope you're understanding. When a specific structure, when a specific graph is given, then we can say that cost is always unique. But here, have we given any structure? No, we have not been given any weight. We have not been given any graph. Okay, we have only been given the edge weights. So it's our responsibility to figure out what is that structure for which we'll get the maximum possible weight. Okay, so the solution is quite simple. Okay, so I have 4 vertices, let's say A, B, C, D. Okay, and it's a complete graph. So it's somewhat like this, and I need to assign weights. I can assign like this 1, 2, 3, 4, 5 and 6. This is the most standard way. This is the most standard way people assign weight. And if for such a graph I ask you what is the cost of the MCST, I will simply apply Kruskal. I will get 1, 2 and 3. The cost will come out to be 6. Okay, the cost will come out to be 6. And this is how almost everyone solves this question, which is a mistake. The mistake is that it's fine, it is the MCST and the cost is 6, but we have to try to get the maximum answer. Okay, so 6 is fine, 6 can be answer, but we have to still check, can we do better? can we create any structure which will have more MCST cost? So what I'll try to do is, again from the proper mindset I told you, again I will think from the topper's mindset. What is topper's mindset? You will try to create your own case in such a way that it leads you to the answer. What do I mean by that? Do I have any choice with one? Will one single edge ever form a cycle? Do I have any choice? No. No. Okay. So no matter what happens, one will always be part of MCST. Then I will assign two. Can two ever lead to any cycle? Can two edges in a complete graph ever form a cycle? No, not possible. Not possible. But can three edges form a cycle? Yes, three edges can form a cycle. So I will try to assign three in such a way that it forms a cycle. This is forming a cycle. Why have I done that? I've done that so that I have to avoid this. How many of you understood the logic? I'm doing that because I have to avoid minimum cost edges in the MCST. And then I will pick 4 and 5 and 6 in any sequence. It doesn't matter. So when I try to create MCST, I will pick 1, I will pick 2, I will pick 3. Can I pick 3? No, 3 is not a possibility. I will skip and I will have to pick 4. I have no other choice. And this way, the maximum possible weight of the MCST comes out to be 7. Are we all on the same page? On the same page? Yes or no? Everyone clear? Very important concept. Okay, now a very important doubt is, sir, why are we not taking 6, 5 and 4? If we want maximum, why not 6 plus 5 plus 4? Any reason? 6 plus 5 plus 4 will give 15, which is the maximum possible. Why that's not the answer? Correct. Because then it will not be MCST. There can never be a MCST with 6, 5 and 4. Okay. So the answer is, I hope everyone is clear. Yes, no. Hmm? Great. Great. Awesome. Okay, let's jump on to a very different question. This is another type of question. For this, I will just give you 1.5 minutes. Come on. This is another very unique type of question. Can I do? Oh, sorry. By mistake uh, एक ऑप्शन छुप गया था. ठीक है, no worries. I hope still you solve. So consider the following array with these elements. The minimum number of interchanges needed to convert it into a max heap. Okay. जब भी आपको एक array दिया गया है और आपसे पूछा गया है कि कितने मिनिमम इंटरचेंज लगेंगे, कैन यू अप्लाई हीपीफाई? आप सिंपली हीपीफाई अप्लाई कर सकते हैं. एब्सोल्युटली यस. ओके, तो सबसे पहले आप गिवन गिवन डेटा से हीप बनाएंगे, सीबीटी बनाएंगे, कंप्लीट बाइनरी ट्री. 89, 19, 50, 17, 12, 15, 2, 5, 7, 11, 6, 9 and 100. दोस्तों, as I have promised you, I am giving you heap, different heap questions, so that this topic is also done, because yesterday this topic remained. So as per my promise, I am giving you heap questions so that you can revise heap topic as well. Okay, so please try to solve them. Perfect. Okay, now we have to apply Heapify, and in Heapify we start from where? Second last level. Okay, so we'll start from 15 because 2 is a leaf. We'll start from the rightmost non-leaf. We'll first check for 15. 1509. So one swap will be required here. 100 will come here, 15 will come here, one swap. Then 12, 11, 6, no need to any swap. 17, 5, 7, no need for any swap. We'll go ahead. 50. 50 will be compared with its maximum child, which is 100. And if the maximum child is greater, you will have to swap. So 100 will come here, 50 will come here, and again 50 will be recursively compared with its fourth child, but no. So one more swap got required. Okay, then you will come to the 19 element. 19 will be compared with its maximum child, which is 17. As 19 is greater than 17, do we need to do anything? Do we need to do anything? The friends, do we need to do anything? We need to do anything. Do we need to do anything? Do we need to do anything? बताओ. No, we don't need to do anything. We don't need to do anything, my dear friends. Okay, so 19 also nothing to do. Then you will go to 89. Then you will go to 89. 89 will be compared with both of its child, 19 and 100, and maximum child will be swapped. So third swap will be required, 100, 89. And again 89 will be compared with its 15 and 50. No need to do anything. Okay, so total of 3 swaps are required. The correct answer is D. Okay, समझ गया? Did you get it? Yeah, it was Chinese English. That was Chinese English. Okay. Nice. Is this clear, my dear friends? Please tell yes or no. So these types of question can get asked where you have to understand the internal working of Heapify. Okay. Yeah. Awesome. Okay. Second important point. If they would have said, listen carefully, listen carefully, listen carefully. If they would have said, by inserting one element at a time, if they would have given this restriction to insert one element at a time, which method would we have used? Which method we would have used? Heapify. Can you use Heapify when one element at a time is to be inserted? Insertion method. Insertion method. Insertion method, my dear friends. Build heap. Build heap and Heapify same wise. Build heap and Heapify is same. Insertion method. Okay, you would have used insertion method. So as a homework, you can try insertion method. Okay, but are all of you clear? Are all of you clear? Are all of you clear? Okay, nice. Sir, American English, please. I don't know American English. Sorry for that. Let's have a look at a bit unique question. I am looking for give me a second. I have brought one very unique question for you. Okay, no. This is the question that I was looking for. Very, very unique question. For this, 3 minutes should be sufficient. Very, very good question. Class will end in around 30-35 minutes max. Okay, so please solve questions quickly. I have few very important questions left. Once they get covered, we'll just end the session. In max 30 minutes, it should be done. Okay, covered. Okay, so very important. Okay, please pay attention. Assume that a merge sort algorithm in the worst case takes 30 seconds for an input of size 64. For an input of size 64, merge sort takes 30 seconds. Which of the following most closely approximates the maximum input size? The maximum input size for a problem that can be solved in 6 minutes. Okay, my friends, this is a very important question. The reason it is important is it can be asked for any sorting algorithm, not just merge sort. If instead of merge sort I can put quick sort, Reddick sort, no, not Reddick sort, I can put quick sort, I can put bubble sort, insertion sort, anything. Okay, because the process is standard. So around 10 to 15 different questions can be solved once you understand the logic. Do I have your full attention on the screen? Do I have your full attention on the screen? Okay. The process is standard and the exact same process can be applied to solve any such question on this topic. Okay, not just merge sort, any sorting technique, standard process. Okay, see, so basically here it has been given in worst case it takes 30 seconds. Does it matter? For merge sort, will it matter? Worst case, no. For merge sort, whether it is merge sort, whether it is best case, worst case, both are n log n base 2. Okay, so it doesn't matter. It doesn't matter. So given information is that we are applying merge sort, and for n equals to 64, it takes 30 seconds. It takes 30 seconds. And we have been asked how much time will it take? Sorry, how many elements can be sorted in 6 minutes? Okay. So many people solve such question by doing cross multiplication, but that's a wrong approach. Okay, that's a wrong approach. We have to understand the meaning of this. Okay, so do you agree for n elements it takes order of n log n base 2 units of time? It is order of n log n, but it is order, and order is approximation. It is order and order is approximation. So do you agree if I want to convert it to time, I can do c times n log n base 2. I can take a constant of proportionality to convert this to exact value. Here it is order, here I am writing value. Is this point clear, my dear friends? Please tell me. Are we on same page? Now for n equals to 64, this is 30. So 30 equals to 3 times 64 into log of 64 to the base 2. What is 64? 2, 4, 8, 16, 32, 64. 2 power 6. 2 power 6. Okay. So 30 equals to c times 64 into 2 power 6 base 6. यानी कि 30 equals to C into 64 into 6, and if you want to further simplify, you can say C equals to 30 by 6 into 64. We will always first find the value of C from the given information. This is the standard process. We will always find the value of C from the given data. Once we have found C, then we will use this C to solve for the required answer. Okay, so now for required answer I have 6 minutes. 6 minutes means 6 into 60 seconds. Why I'm converting to seconds? Because I know that in terms of seconds I have solved the question. So for how many elements I can sort in this much time? So let's say I can solve x elements. I can sort x elements. So C into x log x to the base 2 will be equal to 6 into 60. And I just have to put the values. So x log x to the base 2 equals to 6 into 60 divided by C. That means the reverse of C. Are we all on the same page? Are we all on the same page? Yes or no? That's it. And 30 and 60 gets cancelled. This becomes 2. So 6 into 6 into 2 into 64. Okay. And you just have to put the value of x. You just have to put the value of x to get the answer. Okay. So what value of x is satisfying this? What value of x is satisfying this? Hmm? You can just put the options. If you put 512, so this becomes 512 into log of 512 base 2. So 512 is what? 2 power 9. 2 power 9. So this comes out to be 9 into 512. And you can just check what is 9 into 512. So this is 36 into 2. 36 into 2 is what? 74. 72. 72 into 64. Does this match? Does this match? Does this match? 72 into 64 and 512 into 9. Does this match? 4608. So both are 4608, right? And this is how you can solve this question. Is the concept clear? Is the concept clear? Okay. See, there's no point giving break in between because anyways will be done in around 15 minutes. Okay, 15-20 minutes. Is this clear? Please tell that. Very good question. Very good question. Okay. Any sorting algorithm can be asked. Okay. You guys should not make any mistake. Okay. Perfect. Nice. Moving on to a different variety. Actually, for this 3.5 minutes, it's a lengthy question. This is the very first question on the topic of this. You have to figure out what topic is this. Okay. So what topic is this question based on? MCM, matrix chain multiplication. Okay, which is a DP based topic, which is a dynamic programming based topic. Okay, now obviously I will not be solving this the calculation part because there is nothing much to learn. Okay, only I'll tell you the concept of this question as a revision to the dynamic programming side. Okay, okay. So four matrices M1, M2, M3, M4 of dimensions P, Q, QR, R, S, S, T respectively can be multiplied in several ways with different number of total scalar multiplications. For example, there's nothing much. If you know what MCM is, there is nothing to learn in these two statements. Okay, PQRST value is given, then the minimum number of scalar multiplications needed is. So do you agree that it is unnecessarily making this question complicated? The question is looking very complicated, but at the end only two lines are important. That four matrices, dimensions, minimum kitne lagenge? How many minimum comparisons? How many minimum scalar multiplications? Okay. So the point I want to teach you is, which is a very important point. Many a times in GATE exam, the examiner will try to set a very complicated, very lengthy question, but ultimately the question will be very easy. This has happened with me when I was appearing in GATE 2019, actual GATE paper. There was a very lengthy question, but when I read it with a very calm mind, with a very calm down mindset, it was very easy question. And many of my friends just thought that it's a lengthy question and they skipped that question, which was a very easy question. So what is a very important point? That you will never judge the question by its length. Sometimes a small question can be complicated and a lengthy question can be easy. Can you all type yes? It's a simple maths question, only multiplication and addition based question. No complicated at all. Definitely it is a bit time taking, but it will guarantee you 2 marks. It will guarantee you 2 marks. What can be more than this? Even if you spend 5 minutes on this question, 2 marks are guaranteed. 2 marks means 5,000 rank above. Okay, 5,000 rank difference can be made in 2 marks. Okay, I'll just tell you the motivation part here, because again, the question is not important, the mindset is important. You can solve many such questions. I scored 77.33 marks and my all India rank was 60. And my very best friend, who was my roommate as well at IIT Bombay, his rank was 45. My rank 65, his rank 45. And the difference between our marks was not even 1 mark. It was at max 1 mark difference. Are you understanding? Even in top 100, within 1 mark, 15 ranks difference are there. Imagine the difference between ranks at the lower stage. So 2 marks question, my dear friends. 2 marks can get you 5,000 rank better. It can move you from a NIT to a IIT. Okay. So never leave such questions. Even if it takes time, it's fine. But solve them and grab those marks. This is my suggestion. Okay. Okay, so that was the only message I wanted to share. The question is based on MCM. So what is MCM? You have A, B, C, D. Okay, you have to multiply these matrices in this order, A, B, C, D. Okay, so matrix multiplication problem is a parenthesization problem. The number of ways you can parenthesize are the number of ways you can multiply. So you can parenthesize at these 3 places, which can give you A, B, C, D, A, B, C, D like this, and A, B, C, and then D like this. Okay, but what is the size of the smallest problem in matrix multiplication? Two. Okay, so here we have BCD and here we have ABC. Okay, so I can further break this down at 2, BC and then D, or D after CD. Okay, and obviously A. Do I need to further break this down? Do I need to further break this down? Not at all. It is already AB into CD. I will not do anything. And this I can further break down into two parts. A, B, C, and then finally D, or A, B, and then C, and then finally D. That's it. So total how many ways? 1, 2, 3, 4, 5. I have to just solve 1, 2, 3, 4, 5 ways, and I will definitely have my answer. I just have to do multiplication and addition. That's it. Okay. Will you do this? So this is your homework. You have to solve this question. You have to solve one such question before exam. Okay. But I am not solving it because it will unnecessarily waste your time. Okay. So you have to solve this question end to end, and you have to share it on the Telegram channel, where I'll have a look how many of you actually able to solve this. How many of you will try it? Definitely. So definitely try this out and do share it on the Telegram channel. Okay. Perfect. And one last concept which is important in this topic is that when you multiply two matrices M cross N and N cross P, you get a resultant of what size? Hmm? Hmm. Rows from here, columns from here. M cross P. The resultant matrix will be of size M cross P. Okay, but the number of scalar multiplications will be M and P. Is this clear? Is this clear? These 2 points are important. Okay, and you just have to apply these points in the previous question and you will get your answer. Please tell me yes or no. Please tell yes or no. Come on. Okay, perfect. Now is this clear? Okay, so please solve this question. As I told you, just multiplication, addition you have to do. Okay, now I'll just give you one last question of the day, and then we will end today's session. I have brought a very unique question. Where is that? Where it was. Give me a second. This is n square. This is f of n whole square. Okay? This is f of n whole square. One last question of the day. Please solve very, very carefully. And this is a MSQ. Multiple select correct. By this out. Come on, one last question. बताइए. Okay, so tell me, what are the answers? What is the answer to this question? Come on. AD. Okay, AD. ABD. ABD Villiers. ABD Villiers. ABCD. Wow, all four. ACD. Okay. AD. Okay. BC. Okay. बहुत variety है. BD. Okay. Lots of variety. Which of the following statement is true for all positive functions f of n? For all positive functions f of n. Okay. So f of n square is theta of f of n whole square whenever f of n is a polynomial. Do you agree this is true? Specifically when f of n is a polynomial. So let's say f of n is n square. That's it. Okay. So f of n square will be n square whole square, which we know is n power 4. On the other side, f of n whole square will also be n square whole square, which is n power 4. So these two will always come out to be equal for a polynomial. Yes or no? You take any polynomial by the property that a power m whole power n is same as a power n whole power m, which is same as a power m into n. Because of this property, both will always come out to be equal. Okay, so this is definitely true for a polynomial, but with a slightly change. If I take an exponential function, with a slight change, if I take an exponential function, will this necessarily be true? Will this necessarily be true? If I take 2 power n whole square, this becomes 2 power 2n. On the other side, if I take 2 power n square, it is not equals to 2 power 2n. Both are very different. So do you agree? Do you agree first of all that both are not equal? And it is saying that this is order of f of n whole square. That means it is saying that this is lesser than or equal to this. Is this true? Is n square less than or equals to 2 power n, 2n? Is this statement true? No. So I can simply take a exponential function and conclude that this is wrong. This is wrong. Okay. Here it is saying that f of n square is small o of f of n whole square. Okay, but you have to do this. It should be applicable. The property should be applicable for all positive functions f of n. If this is true, can this ever be true for small o? It is small o. If option A is true, can B at all be true? Think about it. Here you are saying A equals to B. And if A equals to B is true, can A strictly lesser than B ever be true? Not at all. Not at all. It can never be true. This is wrong. This is wrong. And f of n square is big omega of f of n whole square. You are saying A is greater than or equals to B. A is greater than or equals to B. Always. Always. What is the major difference between B and A? Here people make mistake. Many of you have said A and D. Here people make mistake. What is the major difference between A and D? Come on, this is very important. That's why I am taking out time to discuss this. Otherwise, I would have left this question. So that is the reason I am discussing this question. The major difference is here it is polynomial fixed. If this is polynomial, this is 100% true. But if I take any function, let's say if I take 1 by n, okay, sorry, if I take let's say, yeah, 2 power n. If I take 2 power n, okay, let me take 1 by 2 power n. If I take 1 by 2 power n, so f of n square will be 1 by 2 power n square, and f of n whole square will be 1 by 2 power 2n. And I know that this is strictly greater than this. Do you agree? This is strictly greater than this. 1 by 2 power 2n is strictly greater than 1 by 2 power n square. Yes or no? Strictly lesser. Strictly lesser. So greater or equal becomes wrong for such a function. For such a function. Okay. Are you getting it? Are you getting it? Most important step. Okay. So even this is not always true. And that's why the correct answer is only B. Now I have given you MSQ just to confuse you. I have given this as MSQ just to confuse you, because many of you have marked D just because it was MSQ and there should be at least 2 correct answers. But that's wrong. That's a very, very wrong approach. Just because it is MSQ, you will not necessarily mark any option. Is this clear? Have confidence. If you are only getting one answer, so it be. Don't unnecessarily mark multiple answers looking at it as MSQ. Okay, so this was a tricky technique. It was a tricky technique I have used just to tell you this particular part. Okay, so with this, my dear friends, I would like to end this session. I hope that this session was value addition to you. Okay, I have tried my best. I have tried my best to cover as many concepts as possible in the limited time. And yeah, I tried to cover unique questions so that you can learn maximum. With this, I would like to conclude today's session. Thank you so much, guys. I wish you all the very best. Okay, for next session, which is on the GATE CS channel, we'll meet at 8:30 for the practice Maha Abhyas series. Okay, with this, thank you so much, my dear friends. I wish you all the very best. Okay, and you can definitely join this Telegram channel for any queries that you have. Okay, goodbye, take care. My name is Aditya Jain, and I've tried my best to give you as much knowledge, as much guidance as possible in this limited time. Take care, goodbye, all the best. Thank you so much. Definitely share your comments in the comment section so that we get to understand how was your experience. And I hope that you enjoyed and learned from it. All the very best for your GATE exam. Goodbye.